The saturation tables can be used to check for the presence of non-condensable gases in a refrigeration system. Dalton's law states that the total pressure is the sum of the partial pressures. This means that if we have 100 psi of ammonia pressure and 10 psi of air pressure, the total pressure will be 110 psi. We can use Dalton's law and the saturation table to identify non-condensable gases at any point in the system where ammonia is saturated.
All right, in this example, we have a condenser, and we're gonna use our saturation tables to assess this condenser to see if we think there's non-condensable gases inside of it. So this condenser has discharge vapor going into it from the compressors. This is coming from the compressors into the condenser. The heat's getting rejected to atmosphere. Out comes saturated liquid, which would drain to the high pressure receiver. That's what's kind of being depicted here. We have a thermometer installed in the condenser drain pipe and a pressure gauge on the high stage discharge pipe entering the condenser. And let's say we've measured the pressure gauge reading 155 psig and our thermometer is reading 86, and we're asked to figure out, is there non-condensable gases? Well, what I'm going to do is use my saturation table for ammonia, and I am going to find 86 degrees Fahrenheit, right? I found that here, and I'm going to determine what the corresponding saturation pressure would be. And at 86, the corresponding saturation pressure is 154.1. 154.1 is very close to 155, so I would conclude that there's no non-condensable gases. Keep in mind, a pressure gauge, its graduated scale is such that it's kind of difficult to depict a difference between 1 or 2 psi anyways, so our situation is good, no non-condensable gases. Now let's do a new scenario. Erase my numbers that I wrote down. And now let's say we don't even know what the pressure is, but we do know the temperature at the outlet is 90 degrees Fahrenheit. Okay, so we could predict what we think the pressure should be by using our saturation table. Let's go to 90 degrees, and it should be 165.5. Again, because our pressure gauge won't be precisely graduated, I'm just going to go ahead and round that off and just say 165 in this case. We would expect the pressure to be about 165. Okay, that's approximation. But if I'm an operator and I go look at my condenser and I look at the gauge and I see 180, the gauge is reading 180 psi, the gauge, what would that tell me? Well, something's off. Why is my temperature off from my pressure? Well, it very well may be the presence of non-condensable gases. And if that's what we deem it to be, we could also calculate that we have approximately 15 psi of non-condensable gases. And that's the difference between 180 and 165. So that's how you can use the saturation tables to find and assess your condenser for non-condensable gases.